Welcome to Science Tech, the channel where we uncover the hidden science behind the everyday world around you. Today, we're diving into one of the most magical transformations in nature and technology. A process so ancient, yet so essential, you probably looked right through it today, literally. Yes, we're talking about glass. But not just glass as an object, we're talking about how it's made. How something as ordinary as sand, when touched by intense heat, transforms into one of the most useful materials in human history. From the smartphone in your hand to the windows in a spaceship, glass is everywhere. But have you ever asked yourself, how does this crystal clear material come from something as dull as sand? Get ready to be amazed by fire, fusion, chemistry, and centuries of human ingenuity. Let's start with the basics. What exactly is glass? Glass is not a solid in the traditional sense. It's what scientists call an amorphous solid. That means its atoms aren't arranged in the strict, repeating patterns you'd find in crystals like quartz or diamond. Instead, glass is more like a frozen liquid. Its atoms are in a disordered state, locked in place by cooling, but never quite settling into a perfect structure. This gives glass its signature properties. It's transparent, smooth, and brittle. And although we think of it as natural, it's engineered. It's sand, transformed through incredible heat into a stable, clear, durable material. But not just any sand. Glass starts with silica sand, a special kind of sand made mostly of silicon dioxide, SiO2. This sand is usually mined from riverbeds, beaches, or deserts where high-purity deposits can be found. To make glass, the silica content usually needs to be over 95%. Pure silica melts at around 1700 degrees, or over 3000 degrees, hot enough to vaporize metal. That's why most glass-making processes involve fluxing agents, like soda ash, sodium carbonate, which help lower the melting point to something more manageable around 1000 degrees to 1500 degrees. Other additives, like limestone, help stabilize the final product, so it doesn't dissolve in water or react with air. Once the raw ingredients are gathered, silica sand, soda ash, and limestone, they're weighed, blended, and fed into a furnace. This is where the magic happens. A glass furnace is no ordinary oven. It runs 24 hours a day, 365 days a year, and can reach temperatures exceeding 1500 degrees. Inside the furnace, the mixture melts down over several hours into a glowing, molten mass, a golden orange lava of potential. Impurities rise to the surface or are chemically neutralized. The process is carefully monitored to ensure consistency, clarity, and viscosity. Depending on the type of glass being made, metals like iron, cobalt, or selenium might be added to give it color greens, blues, or deep reds. Now the molten glass is ready for shaping. But how do we make it into windows, bottles, or touchscreens? Let's start with the most common method, the float glass process. Invented in the 1950s, this technique revolutionized modern architecture and electronics. Here's how it works. Molten glass is poured onto a bed of molten tin. Because tin and glass don't mix, the glass floats like oil on water, naturally spreading into a perfectly flat sheet. It's slowly cooled on a conveyor belt, a process called annealing, which relieves internal stresses and prevents shattering. For bottles, the molten glass is dropped into molds and blown with air. For fiber optics, it's stretched into hair-thin strands that carry light faster than electricity. Not all glass is created equal. Depending on the recipe and process, we can make tempered glass, which is heat-treated to make it stronger and safer. Laminated glass, used in car windshields, with layers that hold together on impact. And borosilicate glass, like Pyrex, resistant to thermal shock. Optical glass, used in telescopes and microscopes, requiring atomic-level precision. And even smart glass, which changes transparency with electricity. These types of glass enable everything from skyscrapers to smartphones to scientific breakthroughs. So what's next for glass? Researchers are experimenting with flexible glass, self-healing glass, and glass that conducts electricity. In solar panels, advanced coatings help glass capture more sunlight. In construction, new glass can insulate better than concrete. And in medicine, bioglass is helping to repair bones and tissues. From the ancient sands of the Sahara to the touchscreen of your next phone, glass continues to evolve. Outro, 2330 to 2500. So the next time you look through a window, hold a glass, or tap a screen, remember, you're holding transformed sand. You're looking through a frozen fire, shaped by chemistry, physics, and human curiosity. From grains of sand to engineered brilliance, that is how glass is made. Thank you for watching Science Tech. If you enjoyed this journey into how things work, make sure to like, subscribe, and hit the bell so you don't miss the next story of everyday science. Until next